And welcome back. First video we showed you a quick tour of the 4 buttons on the main screen of the CF6.1 touchscreen. Now I'm going to take you through a series of introductions to the buttons below. Each button in turn we'll start with, we'll say kind of where would we be going in here in the first place and what can we do when we get here, and do we have to go anywhere else to finish the job. The first button in the series is Setup. Okay, so as we say, there's 4 buttons here on the screen. The first one we go into is Setup. When we are, let's say we've just installed the firmware. In this case it would be the CF6.1 Community Firmware, version 6.1 firmware. And the touchscreen coloration you see here, this color scheme is the Refactored touchscreen, which will work on all versions of DGIS. So when I go to Setup, what I'm doing here is not necessarily from top to bottom of the menu. Here it's you can touch, you can go for anything you want in any order you want. But what we've said is the very first thing you should do, let's say you've just installed the fresh firmware and there's no assurance yet that the electrically erasable programmable read-only memory called EEPROM on your motherboard actually contains the settings programmed into Configuration H and Configuration Advanced H in the Marlin. So what we want to do to start with is ensure that everything we programmed in the firmware is going into the motherboard EEPROM, and we do that by pressing Restore. Okay, so you'll get a confirmation message you see scrolling on the bottom there, Restore Default Settings. Please turn your printer off and then on to complete the reset. So certainly, sir. Off she goes. And on she goes. Now we have done a factory reset. Well, what's called a factory reset. It's not much of a factory anymore. It was factory when it came from Creality to load up the firmware. Now it's the community reset. So go back into Setup now, because we've wiped anything we did that was custom, right? My PID tuning's gone, my bed leveling is gone, and my E-steps are gone, and now I'm going to have to reset all that. What I could have done before I did that, by the way, I suppose logically it would have made sense to first make sure I'd actually loaded what I thought I'd loaded. Here in the top 3 fields, you're getting information from the Marlin config files. You're seeing the build volume here at the top. That's programmed into the configuration files. You're seeing which version of the firmware we're looking at, because that gets edited every time we put out a new version. And you're seeing the address, although it's not clickable here. This is the address to the GitHub where you would go get the firmware itself, file issues, research, documentation, anything you want to find about from the community in GitHub for this firmware starts there. What I've done here now is I've branded the touchscreen version in here. I went through several release candidates because I was in a hurry to put out solutions for people who were suffering, but at the same time, when I work in a hurry I make mistakes, and I make plenty of them. So I gradually refined the firmware through a series of release candidates until I got to this version, which I consider the final and usable version. You may have noticed the screen dim. I'm not sure whether the camera factored that out. Is one of the settings that's available on here as a standby mode, where the screen starts out bright while you're playing with it and then goes dim to save power on the screen when you're not working with it. So I'm going to go back now. I've done the info thing. I'm going to start out with miscellaneous settings. Miscellaneous settings here at the top is where the screen brightness is controlled. So I can make it stop dimming itself simply by turning off the standby feature. I could also change how long it takes to go to standby here by typing in something, if I want every 10 seconds it goes dim. I happen to prefer 60 seconds. That's what I have programmed into my configuration file. I could make it drop just down to 20%, let's say, because that's a lot easier for me to see and the camera still prefers it. So we can go back to 20 everywhere, and now the camera will see a consistent 20% and I'll be able to read it. So that's what I did there. That's miscellaneous settings. There are two other settings here. Your filament runout sensor, I have in my firmware programmed it to be off by default. I'm chasing some problems with my printer right now, and I am trying to take potential contributing factors out of the circuit. So one of the things that happens when you pull on the filament with the CR6 SE, it tends to transfer forces to the gauge, which then biases the gauge, and my Z offset is inconsistent right now, and I'm troubleshooting maybe that's a contributor. So I keep the filament sensor out of my system unless I'm on a very few meters left on the reel and I'm doing a print I think might run out and I want the protection, and then I can just turn it back on. So some of you are a similar situation. Maybe your filament sensor is not working well, or you want to troubleshoot whether it's contributing troubles. With this interface, you can switch off and switch on the use of the filament sensor by the printer. The other one is power loss recovery. So when you're printing from an SD card, you can ask the printer to keep a record of how far it got so far in the print. It'll keep writing to the file, PLR file they call it for power loss recovery, onto the SD card. This will not work when you're printing from a host like Octoprint. It won't give you that protection, but it will if you're printing from the SD card. And you can disable that feature if you wish, because in some people's minds the board is wasting time talking to the card when it should be paying attention to G-code commands, and there can be issues. People think with the quality of the print if it's doing that. I can't say for sure with any particular motherboard that that's the case, but it has been on other printers, and that belief has carried over here. So if you want to turn off the power loss recovery or turn it back on, you do that from here, the miscellaneous settings screen. So that was here. Let's just work up the screen. Info we've done, miscellaneous settings we've done, we did the reset from factory, and now because you're looking on my screen at the refactored touchscreen firmware, there is a button here that will not be present on the 6.1 bundled version. I added this button while I was helping someone gain access to the screen. They were having trouble on their machine, and I decided, you know what, this is a setting. This is a setup setting in the philosophy of the user interface. It's been missing from here, so let's add it. So now you can go here, and what it gives you access to is, on the CF6.1 we go to a lot of trouble to try and optimize the bed mesh. We try to get the bed leveling function working to its absolute best. And the series of controls that are available here are normally available from the calibrate menu, and I've added them here. They're in both places now. So the fade height is a reference to when does this leveling fade away, when do you stop applying the correction factor. You can put a value here. It's defaulted to 10, so by that point the leveling should no longer make a difference. Your print is pretty much all working at the same level now because it's flowed in and leveled itself. But the stabilized temperature after probing is a toggle switch. Notice the X and the check mark, those are cues along with bright and dark. On the interface, the philosophy is if it's a toggle and it's dark, it's switched off or disabled. If it's bright, it's switched on or enabled. And the word stabilized temperature after probing reference when we do probe and we have better accuracy turned on, the temperature of the heater rather for the nozzle is turned off during the probing effort to reduce the probability of electrical noise interfering with the gauge. So when you come back up at the end of probing, the probe might wait. If this is switched on, it'll wait until the temperature recovers at the end of all the cycling or at the end of the homing, and then it'll return to the next step. If you switch this off, it will not wait for that temperature to recover before moving to the next step. That's what that's for. These are the temperatures that you're going to use for probing. Now that's whether you're homing or doing ABL. If you're probing, it's going to warm the nozzle to 145 if it is not already, and it's going to warm the bed to 55. If you wish to change these values, you can do that. Anytime you tap a modifiable value, you can type in a new number, and when you leave here, it will store it to your EEPROM. I want to leave that, in my case, where it was. So these are the values. It might, I've seen some people mention, hey, now that I'm printing, every time I want to print with PLA, my slicer says 50, I start homing, and the damn thing goes up to 80. What the hey? If you come to this screen, what may have happened is you may, at some point, have decided you want to do leveling to print with, say, PETG. You know it's going to run at 80. You suspect it might make a difference to your leveling mesh. So you've come here and you've set it to 80, and then you've gone away and not changed it back. And now it's sitting here at 80, and every time you come to print, it goes to the higher of the values, which in this case will be 80. If you left it at 55 here, and you printed with your slicer settings at 80, it would go to 80 for printing, but for probing it'll be at 55. And the better accuracy business is what I mentioned earlier. It doesn't tell you anything here when you push it, and there being no user manual, you have to actually get into the README file a little bit to find out what this is for. What it's doing there is turning off the fan if it's running, it's turning off the heaters, and it's making sure there's a minimum electromagnetic interference environment for the gauge during the probing. We recommend you leave it on. If it's bothering you that the temperatures are going up and down, and truly it's not making a difference to the measurements you're making other than to eliminate the noise, but if that behavior bothers you, you can switch it off. We suspect you will get a worse bed mesh by doing so. So that's why it's called better accuracy, and that's the recommended default setting. So that's it for leveling. Movement settings are about the stepper motors and their drivers. So we have the X, Y, Z, and extruder motors are controllable from here. There's their setups. In each case we have steps per millimeter, max acceleration, jerk, and max feed rate programmable directly from here. So rather than having to recompile the firmware to change steps per millimeter, for instance, you can simply tap a value here and make the change. By the way, you can always hit the X when you shouldn't have done that. In my case, I have a 0.9 degree motor, stepper motor on my y-axis. It's twice as many steps per millimeter as the 1.8 degree motor on my other axes, so it's 160 here. And acceleration, jerk, and feed rate I am not messing with yet. At some point when I start trying to speed up the printer with optimal performance, I'll be able to come here and change the values that I want. And by the way, looking ahead at Marlin 2.1, we're presently at 2.0.8 with CF6.1, but at 2.1 classical jerk is not turned on by default anymore. They're going with something called junction deviation, so this interface would probably be revised here to let you get that new value, but that's me talking for the future. Present is it's classical jerk, and that's the value that is programmed in by default. So extruder is where most people are having to make changes if they are upgrading to something like I have the Orbiter version 1.5 installed here. My last calculated steps per millimeter was 663, which is a fair bit off the 93. I set that up because we did a firmware reset. We know that's what my firmware value is, but doing E-step calibration later in the series, I'll show you that that value is going to change up again, I think, when I make my next calibration. But in every case you have these values, you set them to the values that work best for that axis. Down at the bottom here, you've been seeing TMC settings. That's appearing on my display because I have a BTT SKR CR6 motherboard. This button will not appear if you have a Creality motherboard, because to make these changes you have to go to the motherboard with a screwdriver. I'm able to type in a different milliamps, different current for my extruder right from here, which was very handy because the motors tend to come with different settings than the stock. I can control whether Stealth Chop is operating or not on any of the axes, and I can control at what threshold I get a hybrid switch between Stealth Chop and that other mode whose name I keep forgetting. So that's movement. Under advanced settings, by the way, you have access to this set of parameters: minimum segment time, feed rates, normal acceleration, retract acceleration, and so on. You can change all of that from here on the interface. Temperature settings. Here we're talking at the bottom here, we see preset values. You could read this as preset 1 and preset 2. It's a bitmap. Unfortunately we can't make this word change by changing it in the configuration file, which you can on the LCD screen version of the Marlin menu. But being a bitmap, we're locked into these words. We chose the words PLA and PETG as two most popular print filaments, and all the folks who print ABS went, hey, what happened to my ABS tag, because now it's labeled PETG. Sorry. But there are two presets here, and those are the two names. Translate in your head for whatever you're actually using them for. Just think of them as preset 1 and preset 2 if these are not your favorite filaments. In either case, we can choose to say, okay, every time I say warm it up to preset 1, or in this case PLA, these are the temperatures I want you to use for the nozzle and for the bed. And you can change that value. I can say I want all my PLA to be printed at 205. So now when I show you the prepare menu and I show you preheat to PLA settings, it would use 205. As it happens in my case, I prefer the 200, so let me just change that back while I'm here. And PETG is the same deal, just two different values. Right? Same functionality. Pit tuning. Pit tuning is something we're going to need to do because I reset my printer and now I need to reset the pit tuning parameters. I'm going to set it up to pit tune at 200. I like to run the fan. In this case though, I've unplugged the fan to keep the noise down while I'm making videos, so it won't make any difference if I turn that on. But you could say do your pit tuning with the fan on or off, your choice, whichever you think gives you better results. You can change how many cycles it goes through. I tend to choose 5 or 7 because I read the documentation in the code and it suggested that was better. I do not know that's still to be true, it just did it last time they documented it. But the default value here is 3, and 3 seems to work just fine for most of our users. And to run PID, you simply see the message there says ready. When you do that, it says PID tuning, please wait, and it tells you it's in auto tune mode. Now I haven't spoken about them before. I probably should have started on the main screen with the bottom here, but this symbol here is a nozzle, that symbol there is a heated bed. The first value in each case is what does the thermistor there measure right now, so the ambient around here is 18 degrees C, and the nozzle is already measuring as it goes up towards the target value. But the target value when you're running PID does not change. Don't know why, how it's been coded by Marlin. It stays at 0 the whole time that you're actually running up. So you can't use this to confirm what target has been set. Target set value was up here, 200 is where it's going. When you see this get up around 200, it'll overshoot a little bit, and then it'll pull back down. It may be undershoot a little bit and go back up, and it'll take 3 cycles, because that's what I asked for here. It would have gone 5 if I said 5. When it's all over, you'll get a beep that says PID tuning is completed. That's to draw your attention back to the machine if you wandered off and got bored, and there'll be a message there that says PID tuning is completed. I'll probably speed this up in the playback just to take you to the punchline, because it's sucking minutes out of my YouTube video duration, but I'm going to endure the whole thing, and I'll be back to you in a minute when it goes beep. There you go. PID tuning is done. The value has been stored in EEPROM, and we can leave this screen now. That part of setup is complete. Fan on and off is just a local control. I can do this in real time. If my fan was plugged in, it would work a lot better. I can change the temperature of the bed now. I can make it go to 60 right now. You'll see the target has changed and the temperature will start to climb. If I put it back to 0, target changes back to 0 and it stops climbing. Same thing is true of the nozzle. I can say start heating up the nozzle right now. Let's say I'm setting up my printer, I want to change a nozzle. I want to get it up to a temperature before I try to undo it. That's where I would be and that's how I would do it. And then I can go back to 0 and I'm done here. That's it for temperature settings. Now, the other two settings up here are basically toggle switches. You hear it beep every time I touch a control. That's every time this touchscreen recognizes having been touched and activated a control, it will beep. I can turn that sound maker off. See a little X now instead of the radiating sound. I can hit buttons all day, no beepy noise at all, so if that's what you prefer. If you like to get confirmation that something's been touched, leave the sound on. I happen to leave the LED off most of the time, and I turn it on when I want to see what I'm doing underneath the nozzle. So you can set up the default here. When I switch off power now, I've got this selected on, you see? Can you see? Yes? And I turn that printer off, and then I turn it back on. The light is now on, and the light's on because I left it switched on. If I go to setup, I turn the light off, I power off, I power on, the light comes on briefly while the SKR board is booting. Now it's off because I left it switched off. So that's setup, that's the philosophy of setup, and those are the controls that were on there. The next menu we'll go to is calibrate, and I will correct my mistake here. Let me start by telling you what's on this screen at the bottom, which we haven't even spoken about. There are 4 attribute displays down here at all times. On the main screen, this symbol represents a nozzle, this one represents your heated bed. The Z represents your Z offset, and the speed dial here represents your feed rate, the rate at which the bed is feeding the model to the nozzle. In effect, all things being relative. Yeah. So the first number you see is the currently measured number. I've been running demonstrations here, so my temperature is still falling back down from the 200 where I set it. But the target value is 0, means there is no heater target. The heater is not switched on, it's not being asked to do anything. It will fall back down to ambient and stay there. When I select a temperature value, this number shows the value that I've chosen, and that one shows what the thermistor is measuring as it heats up. Same philosophy with the bed. Right now it's looking at ambient temperature. There is no heater requested. If I turn the bed heater on, the value I've asked it to go to is displayed there, and what temperature I'm measuring right now is displayed there. Feed rate is a percentage. The way it's shown, the software doesn't choose a feed rate. It doesn't tell you it's going to use so many millimeters per second. What it does is take the value that the slicer has been programmed to use and multiply by this value. So it'll use the slicer value when this is 100%. It'll use a percentage of the slicer value when this is a different value than 100%. Right, technically it's using the 100% as a percentage also, but what I mean to say is if this is set to 80, then it'll use 80% of the slicer setting as the feed rate. And your offset here is, of course, how far does the head travel before it realizes it hit the bed. So if it's 0.2 millimeters offset there, it means it overshoots 0 by 0.2 millimeters normally. So you set it to 0.2 and it will stop at 0 where 0 is. Right? That's the offset's a complex concept, but that's it in a nutshell. That's what is being shown here. Now you can actually tap the nozzle value, set a number, and poof, it's starting to heat up to 200°C because that's what I typed in, and away it goes. I can go back to 0. So that's almost an Easter egg since there was no user guide. But there you are, you've been told now. You can do the same thing with the bed. I can type 60 and it'll go to 60 quite happily. I don't have to go to setup and do it there. I can do it from right here. I cannot change feed rate or offset from this screen. Those are purely displays of the settings that are loaded in. They are not modifiable from those positions, but these numbers you can change, and some screens you'll only see these two numbers. You won't see these values at all, but you can always tap those to change them if that's what you want to do. Okay, that's it for setup. I hope that clarifies things. If you like it, let me know. If you don't like it, let me know why. If you have more questions, please don't hesitate, leave them on the video. I do find them, although sometimes it might take me a day to go looking. I do find them and I do respond. Thanks for listening. Talk to you again soon. Bye-bye.